So today we're going to talk about memory. First of all, we need to ask, what exactly is memory? Now, the authors of your textbook, Martin, Carlson and Buskisk, they describe or define memory as this process of encoding, storing and retrieving information. So that's quite a specific definition. For a more generic understanding of memory, you can think of it more as this mental function of retaining information about a stimulus, whatever it may be. It might be an event, an idea, a visual image. So retaining information once that original stimulus is no longer present. And memory and learning are intimately entwined, and memory can only occur if there's been previous learning. And many researchers think that there's sort of 3 successive stages that are involved in memory, and that's encoding, storage and retrieval. Now with encoding, that's this process by which you convert sensory information into, well, you have some kind of, you process it in such a way that you give a code to sensory information so it becomes meaningful, you can use it. So you could apply a verbal code, maybe a semantic code, to the incoming information that you receive from the environment. So encoding is the first stage. Then there's storage, which is self-explanatory, it's just where you maintain information. And then there's retrieval, whereby you recover the information that you've encoded and stored. And each of these stages needs to be successful, and they are interrelated as well. Now, previous research has suggested that there's different types of memory. You have sensory memory, short-term memory, working memory, and long-term memory. Now, working memory really is regarded as probably a more sophisticated version of short-term memory. Working memory came about really as a more accomplished version, so it's a more detailed version of short-term memory. So you can almost, some researchers regard working memory and short-term memory almost as synonymous, or they regard working memory as just replacing short-term memory. It's a sort of more detailed model of what short-term memory should be like and how it functions. So early researchers arranged these different stores into a kind of like a very basic information processing model. So you have these 3 early stores: sensory memory, short-term memory and long-term memory. At this point, working memory hadn't been devised, and information travels through these 3 different stores in a fixed sequence. And one thing I want to point out, when I talk about these models of memory from the information processing era, when I talk about them, I'm speaking about them metaphorically. There's no neurological basis to these stores. Yeah, they're just sort of hypothetical constructs or mental constructs. So we talk about each store individually. Sensory memory, this is the store that receives information directly from the external environment. And it holds information in a relatively raw form. There's very little processing that occurs in sensory memory. And some researchers, they find that it's very difficult to distinguish sensory memory from just the mere act of perception itself. Often we're not conscious of our sensory memory. Now, in terms of duration, it really does vary depending on which sense modality you are using. And the same with the capacity of sensory memory. Again, it depends upon the sensory modality. Echoic memory or visual memory tends to be very, very fleeting, whereas iconic memory, tends to be very, very fleeting, whereas echoic memory tends to have slightly longer duration. Well, I'll talk about that in a few slides' time. The main purpose, it's thought, of sensory memory is really to hold information for long enough for it to be transferred to short-term memory. Now, it's thought that there's a sensory memory for every modality, but most of the research that's been carried out has focused on iconic memory, which is visual memory, and echoic memory, auditory memory. Now, some very important research was conducted by a man called George Sperling in 1960 on iconic memory. And he did this research when he was quite a young man while he was doing his PhD. And what he was interested in was both the capacity and the duration of iconic memory. And he devised a paradigm which is called the whole report procedure. And essentially, this is like a matrix of letters, a 3x3 matrix of letters, like this one here, which he flashed up to the participants for a very brief period, just 50 milliseconds, which you can hardly see it, it's presented and then it disappears. Flashed that up to participants, and the participants, once the display was terminated, had to recall as many letters as possible. And on average, the recall performance was quite poor. Participants were only recalling about 4 or 5 items, but they tended to say to George Sperling, we feel that we know more, but can't recall them. And George Sperling wondered, well, maybe the reason why they feel that they can recall more, but their performance is quite low, is possibly they could have a percept, they could have a visual image in their sensory memory of all 9 items, but it could fade, the duration could be so fleeting that it could fade before they can read off all 9 items. They only have time to read off 4 or 5. So the way that George Sperling investigated this further was that he used what's called the partial report procedure. And the partial report procedure is exactly the same as the whole report procedure. You get that same 3x3 matrix. But what happens is expose it to the participants for 50 seconds, but after the termination of the display, he sounds a tone. Now, a high-pitched tone signals to the participant that they've just got to recall the first row of letters, the top row. A medium-pitched tone signals that they've just got to recall the 3 middle letters, and a low-pitched tone signals the bottom row of letters. Now, what George Sperling found was that performance was almost 100% accurate when he gave this task to participants. And what he concluded, because the important point is the participants didn't know what tone they were going to receive until after the termination of the display. So they must have been reading off the percept of all 9 items in order to get this 100% performance, because they wouldn't have known which row they'd have to read. So from this, George Sperling concluded that it's not capacity as such, but it's duration that accounts for that poor performance when he used the whole report procedure. And then what George Sperling did, he carried out a further experiment where he delayed the sound of the tone. So he delayed it by a second. So he flashed up the display, there was a second's delay, then he sounded the tone, and then participants recalled the items. And with this delay of 1 second, he found that performance dramatically declined. And so his reasoning was, by that time, the actual visual image has faded, therefore participants can't read off that percept. And so the upshot of his findings was that capacity in iconic memory is going to be at least, if not 4, more 9 items, but the duration is going to be less than a second. Okay, so moving on, some research that was conducted on echoic memory, so our sensory memory for auditory information. Most sounds are important in terms of echoic memory, but what's particularly important for echoic memory is how we hear speech. Because you think about when you utter a word or you hear a word, it's made up of smaller units of sound, i.e. syllables or even smaller units than that. And in order to be able to fully comprehend a word, you need to have a memory for the first syllable, and you need to be able to retain that until the whole word has been uttered. And only then can you fully comprehend the word. So echoic memory has been researched in terms of speech, and it's important for that. And Darwin, Turvey and Crowder in 1972, they found that echoic memory, in terms of duration, can last up to 4 seconds. So echoic memories last far longer than iconic memory. Moving on to short-term memory. So short-term memory, it receives input from sensory memory. Its capacity is thought to be limited to around about 7 pieces of information, plus or minus 2. And this came from the research of Miller back in 1956 and his magical number 7, plus or minus 2. So capacity is around about 7 items, but you can increase capacity by means of strategies such as chunking, i.e. grouping pieces of information together in a meaningful way. Duration in short-term memory is thought to be around about a maximum of 20 seconds. However, again, you can increase this duration by rehearsal, acoustic rehearsal, rote rehearsal, sort of repeating the information over and over again. You can keep it alive, and also it's thought that this rehearsal transfers that information into long-term memory. Encoding in short-term memory is thought to be predominantly, but not exclusively, acoustic. And there's also visual encoding as well, although it's thought to be less common than acoustic encoding. So just a few words about encoding in memory. A stimulus can be encoded in a variety of ways. So, for instance, you think about a stimulus, the written word umbrella. You can have a visual image of the written word. You can also have a pictorial image of an umbrella. You can also maybe read the written word umbrella, and then by doing that you can read it and you convert it into an acoustic code, or you can think about an umbrella in terms of its semantics, i.e. its meaning. What would you use it for, and what circumstances do you use it for? So there are different ways of encoding and making information meaningful. Long-term memory. This receives input from short-term memory. Capacity is thought to be indefinite. There's no limits. It's thought that people can always have the ability to learn more information. Duration is thought to be almost like a permanent or near permanent basis. And encoding is thought to be predominantly semantic in long-term memory. So in the information processing era, the researchers kind of like organised or arranged all these different stores into a very simplistic model of memory. And the most common one, most memorable one of these is the multi-store model by Atkinson and Shiffrin. And there's kind of like a few features. So you can see the stores are arranged in a particular order, and information flows through the different stores in a fixed sequence and in one direction. And each of the stores are different in terms of their duration, their capacity, and also the way that they encode the information. So let's just have a look at the evidence which supports models such as the multi-store model. Now, a defining feature of the multi-store model is really this distinction between short-term memory and long-term memory. And so we'll look at the evidence which supports that. First of all, we've got neuropsychological evidence. So this is from brain-damaged patients whose deficits give rise to kind of like memory impairments. And a patient of Milner, HM, he was brain damaged. He was epileptic, and he underwent some surgery to cure his epilepsy. And an unfortunate side effect of the surgery was that his long-term memory was impaired. But his short-term memory was unaffected. It remained intact. So there you've got this, what's called a single dissociation. And the suggestion is that if you can damage one system but not another, that means that the two systems are probably functioning separately, independently of each other. So it's evidence for a distinction between short-term and long-term memory. Adding weight to this argument is another brain-damaged patient, KF. And he was a patient which was presented by Shallis and Warrington. Now, KF had the opposing memory deficit. KF was in a motorcycle accident, and KF had a short-term memory impairment, but his long-term memory remained intact. So you've got these two contrasting deficits in both these patients, and what they constitute is what we call in psychology a double dissociation. And a double dissociation is quite powerful evidence that two mechanisms are operating independently, because you can damage one but not the other, and it's like a converse. More evidence for this distinction between short-term memory and long-term memory comes from encoding. So short-term memory relies predominantly on acoustic codes, whereas long-term memory depends upon semantic encoding. Now, you'd have thought if the two systems are together, they would be using the same codes, not different codes. And then finally, a series of experiments was run concerning primacy and recency effects, and these give further evidence for this distinction between short-term and long-term memory. And we'll talk more about primacy and recency effects now. So this was a memory effect that Glanzer and Cunitz discovered back in 1966. It's very old research. What they did is they presented participants with quite a long list of items, and then they asked the participants to free recall the items. That is, recall the items back in any order they wanted to. So not serial recall, but free recall. And what they found was that participants were very good at recalling the first items in the list of words. And this is known as the primacy effect. Participants were also very good at recalling back words that were placed located at the end of the list. And this is known as the recency effect. However, the words in the middle of the list, they tended to be poorly remembered. And the way that Glanzer and Cunitz explained this was in terms of short-term memory and long-term memory functioning. So if you have a look at the graph here, if you take note of the orange line, so you can see, and along the x-axis here, you've got the serial position of the words on the list, and then you've got the percentage of words recalled. And you can see that performance is far higher for the words that are positioned at the beginning of the list, i.e. your primacy effect. And it's thought that this primacy effect represents processing in long-term memory. Because what's happening here, the words are coming in, there's not many, so the participants are able to rehearse them, and that ability to rehearse means that information, those words, go into long-term memory. Hence, you've got a better recall for them. Then you have a dip in performance for these intermediate words, and what's happening here, you're getting more and more words, therefore the opportunity for rehearsal is lower. And also there's more opportunity for displacement as well, new words displacing old ones. But then you can see for this words right at the end of the list, you have performance shoots up again, and this is the recency effect, and it's thought to represent processing in short-term memory. Because you haven't got any words here following at the end of the list, so participants are able to rehearse these words and keep the memory trace alive, hence a better recall. Okay, so this idea of primacy and recency effects, again, gives some further evidence for this distinction between short-term and long-term memory. And Glanzer and Cunitz, they carried out a further experiment where what they did is they delayed recall. So they presented the participants with a list of words, and then before the participants could recall the words, they said, right, I want you to have a distractive task for 30 seconds. Count back in numbers for 30 seconds. And the prediction was that this should kind of like disable your rehearsal of those final words in the list. So it should disable your short-term memory, basically. But it shouldn't affect the primacy effect. It should only kind of like eradicate the recency effect. And this is exactly what happened. When participants had this distractor task, the recency effect disappeared. You can see it on the graph here. So it's this like maroon line. The recency effect disappeared, but the primacy effect remained intact. And what they're saying is that distractor task prevented participants from rehearsing those final items, therefore recall was poorer. And again, this is consistent with the idea that short-term memory and long-term memory are different entities. Okay, so on the flip side of the coin, we're going to look at problems now with the multi-store model. So with regard to neuropsychological evidence, it could be that researchers have argued that the case of KF, who had this impaired short-term memory but long-term memory functioning was intact, some researchers interpreted this as evidence for the multi-store model. But other researchers have come along and said, well, hang on a minute, no. If you think about the way the multi-store model is arranged and the mechanics of it, long-term memory functioning is dependent on short-term memory functioning. So therefore, logically, if KF has an impaired short-term memory, this should impact negatively on his long-term memory. But KF's long-term memory was perfectly okay. He led an independent life. So therefore, some researchers argue that no, that evidence is discrepant, is not consistent with the multi-store model. Another problem with the multi-store model is this idea of recency effects. So recency effects have been regarded as representing short-term memory processing. However, Baddeley and Hitch in 1977 found evidence of long-term recency effects. So what they did is they asked rugby players to recall the teams that they'd played with in last season's matches. And it was found that the rugby players tended to recall the most recent teams they'd played. However, it was last season's play, so it was about 6 months ago. So you can't, so therefore, because it's such a long time ago, a recency effect cannot be representing short-term memory processing. More general criticisms of the multi-store model are basically there's too much significance is accorded to this acoustic rehearsal, and it's far too simplistic, just a rote verbal rehearsal, to account for all types of learning. And some kind of learning is very complex, and just literally repeating yourself cannot account for that. And also there's other types of learning like sudden insight or sometimes learning is particularly quick because maybe a stimulus is, I don't know, particularly distinctive because it's funny or it's emotionally salient. You know, acoustic rehearsal cannot account for those types of learning. Also, another criticism is that there's this overemphasis on structure within the processing model, and not enough detail in terms of, you know, actually how is this processing occurring? You know, what are the mechanisms that's happening? And then finally, and this is quite an important criticism, it's about the flow of information. The multi-stall model says that the information flows just in one direction, whereas there's a lot of research at that time, you know, in the 1970s, which said that no, long-term memory informs and assists short-term memory processing. So therefore, the direction of information must be two-way. And later models of these information processing models were updated to show that this information was actually a two-way. Now, we're just going to have a little group experiment as a class, really just to illustrate to you this point that long-term memory does actually assist in your short-term memory processing. So what I suggest you do is close your handout so you can't see the answers, and there's a few spare pages at the back of your handout, so use that paper to write your answers down. Do you need a pen? So what I'm going to do is I'm going to present some items to you, some letters, and I want you to just look at the display, try and learn them, and then I'm going to terminate the display, and then your job is to write the items down in the order that you saw them. Okay, is everyone ready? Okay, write them down. Now, I imagine everyone found that task relatively easy. Did everyone get 5 out of 5? Them all correct? Yeah, quite a few of you, I imagine so. Okay, we're going to have a second mini experiment. The same procedure as again, but these are going to be symbols rather than letters. Okay, is everyone ready? Okay, write it down. Okay, did anyone get all 5 symbols correct? I thought not. Oh, someone up there, someone clever. Basically, the idea of this experiment is very simple. It just does illustrate how you're familiar with letters. You have that knowledge in your long-term memory, and that assisted you with an immediate serial recall task, which is an index of your short-term memory, whereas the symbols you're not so familiar with, and that's why you struggled to recall them, because you didn't have that long-term memory helping you. Okay, so given the dissatisfaction of the multi-stall model and the fact that it doesn't really fully fit with all the research that was about at the time, this prompted 2 researchers, Baddeley and Hitch, to devise and formulate a new memory, and it was called working memory, and it was really a substitute for short-term memory. Now, working memory, the name kind of like really describes what it is. Because Baddeley and Hitch didn't see short-term memory as something very static and passive. They said that your short-term memory is very active and dynamic, and it actively manipulates information in conjunction with your existing knowledge. So working memory is probably a better title than short-term memory. And another way that this new version of short-term memory, which is called working memory, is different from that which was described in the multi-stall model, is it was made up of different components. So it's not a unitary system, it's a multi-component system. And the components that it's made up of are the central executive, the phonological loop, the visuospatial sketchpad, and the episodic buffer. Now, the episodic buffer is a later addition to the working memory model. And I just want to point out it's not in your textbook. And I don't know why your textbook hasn't been updated, because it was added in 2000, the episodic buffer. But just be aware of that. Look to my notes rather than your textbook for the episodic buffer, because the textbook hasn't included it. So this is more of a diagram of the components of working memory. So the central executive really has overall jurisdiction over these three slave systems. And you can see that the system's interactive and it works with long-term memory. So we'll go through each component in turn and talk about it. So the central executive, again, is the overseer of the other slave systems. It's the most powerful component. It controls attention and it's responsible for regulating the other slave systems. It's thought that it can process information from any modality, and it's also thought that it has limited capacity. And if you think about it, when you're working something out at a time, there are so many things that you can focus on. There are limitations to your attention and your concentration. Now, researchers don't really speak about duration with the central executive because it's thought to be a processor rather than a form of storage. And also with the central executive, it's quite an abstract concept, so it's quite difficult to set up a specific prediction and then test that empirically. And as such, there isn't that much research to support the existence of the central executive. The phonological loop. Now, the purpose or the function of the phonological loop is thought to be that it processes speech-based or verbal information or any kind of sound, but particularly speech. And the phonological loop has two subcomponents, the phonological store and the articulatory control process. So here's a diagram of the phonological loop. So you can see you've got this phonological store here, and that kind of like obligatory receives speech inputs. You know, it can't help it. And it stores information, like speech inputs, for about 1 to 1.5 seconds. And if this information isn't refreshed in any way, it will decay. And then you've got the articulatory control process. Now, the purpose of the articulatory control process, or this loop, is to refresh the information in the phonological store so that it doesn't decay. And it refreshes it by subvocal rehearsal, so saying the words either in your mind, under your breath, etc. Or it can be out loud as well. That will do the job, it will refresh it. So it keeps the verbal information alive and restores it in here. Another function of this control process is that it converts non-speech inputs into a verbal code. So for instance, if you're reading some writing, you kind of like do it subvocally, and then it's in a verbal code and can be stored in the phonological store. Now, as I said, Baddeley and Hitch, they devised working memory to try and fit with the existing data and research. And there's certain memory effects that have been found when there's been work done on short-term memory. And if the phonological loop is an accurate account of how our memory works in the short term, then the phonological loop should be able to account for these different memory effects that have been found by research. And one of these memory effects is the word length effect. And quite simply, the word length effect is where if you give participants a list of long words, their recall performance is going to be worse than if you give them a list of short words. Okay, that's all it is. And this effect, this memory effect, does fit with the phonological loop, because if you think about it, if you go back to the diagram, this phonological store only has a duration of 1.5 seconds. So the articulatory control process has only got 1.5 seconds to kind of like refresh the information, and it takes longer to utter long words than it does short words. Hence, you're more likely to be able to retain the more short words than long words, purely because it's a time frame thing, it's a time situation. And it's also been found that people who talk quickly tend to have a better or a higher verbal span, because they can fit more into that articulatory control process, more into that 1.5 seconds. So you're going to experience the word length effect yourself now. So again, you need to close your handout so that you can't see the answers. Go to the back and have your pens at the ready. So again, this is an immediate serial recall task, so it's a measure of your short-term memory. I'm going to present to you a series of words, and you've just, when I end the display, you've just got to write them down in the order that you saw them. Okay, everyone ready? Okay, you should give yourself a grade. So for every right word, it's got to be in the correct position as well. Give yourself a mark. Did anyone get 7 out of 7? A couple of people, not many. It's quite difficult. Going to have a second word length effect span test. So have your pens at the ready, same procedure. Okay, mark your work. Hands up who got 7 out of 7. No one? Yes? Hands up who, did you all do better the second time than the first? Yeah? Okay. So yeah, it should have been easier. So essentially that's just the word length effect. I just have some quiet, please. But the important point is that the phonological loop can account for that effect. Okay, another memory effect is what's called the phonological similarity effect. And simply this just really is a person's ability to perform an immediate serial recall task is going to be affected by the type of words. So words that sound similar phonologically are far more difficult to recall and performance will decrease. However, words that are distinctive in terms of sound are going to be easier to recall. And again, this is consistent with the phonological loop because the phonological loop is based on a phonological code. So you would expect phonological similarity to create confusion in that phonological store, whereas distinctiveness should enhance performance. So you guys are going to experience the phonological similarity effect. So usual procedure, close your handouts, pens at the ready.